Okay, I redrew the problem. This is the third video. You first learned what a slope field ought to look like when completely graphed. Then you did some prereq skills. And so this third video is where I'm actually going to teach you how to draw a slope field. I'm just playing around with my lighting. Probably don't have time to edit this, so you're going to see me trying to do. I'm just going to have to leave it, I think, the way that it is. Okay. So this is on the second page of your packet. It's the very first question. And you are given a grid that has 9 predetermined points drawn. And so if you watched the first video, which I really hope you did, or this isn't going to make any sense, the slope fields were on a much larger scale, and you can play along if you'd like with Desmos. You can Google Desmos slope field generator, and you can type this in yourself into Desmos and see a much larger field. But we're doing a straight up AP College Board FRQ. Every problem in this packet was an actual FRQ given in a recent year. And so I'm going to teach you how to get a 9 out of 9 on this question should it make its way onto your test. Okay, so what you do is you go to the points that they decided that they want you to draw the field, because it would take a lifetime for you to draw a field by hand the way that Desmos drew in video 1. You do not have to do this next part, but just for the sake of teaching, I'm going to take each of those 9 points and I'm going to put them in a table. So for example, this is the point 1, 0. This is the point 2, 0. This is the point 1, 1. So I'm going to go ahead and write those all in a table and pause it, and then I will be right back. Okay, I'm back. I have all 9 coordinates in this chart, and now I'm going to take the coordinates and I'm going to plug them into the dy dx, where I go back to thinking about this as a slope spitter outer. So I'm going to go ahead, for example, and plug in 1, 0 into my slope spitter outer, and at 1, 0, figure out what the slope is. Then I'm going to plug 2, 0 into my slope spitter outer, and then I'm going to figure out at 2, 0 what my slope is. So for example, at 1, 0, if I plug a 0 in for y and a 1 in for x, I would get out -1 over 1, which is -1. If I plug a 2, 0 in, 0 in for y and 2 in for x, I would get out -1 over 4, so -1/4. Let's do one more, and then I'll show you what you do with these. If I plug a 1, 1 in, I'm going to plug a 1 in for y, and 1 minus 1 is 0. 0 over 1 squared is 0. And so I would get out a 0. So what you do with this is you go to these spots in your slope field grid, and I'll go back to my worksheet in a second. And if you go to 1, 0, you want to draw at 1, 0 a tiny itsy bitsy tangent line or a little vector that looks like it could have a slope of -1. Then if you go to 2, 0, you want to draw a tiny little vector, a tiny little tangent line that looks like it could have a slope of -1/4. Now this is all relative. As long as this looks less steep than this, you're golden. At 1, 1, I determined that the slope was 0. So if I go to 1, 1, I want to draw a tiny little tangent line that's horizontal, that looks like it has a slope or a derivative of 0. And now we need to play this game 1, 2, 3, 4, 5, 6 more times. So let's pause and have you plug some points in on your own. Draw some tiny little tangent lines that look like they have a certain slope. We can join back up, and I'll go to my worksheet and I'll show you how to finish this problem. Okay, I'm back. I did this problem earlier, so these might be in a slightly different order. But if you want to pause right now and just compare my numerical slopes to your numerical slopes, I think that would be a good idea. And then also compare each of my little mini tangents to your mini tangents. The College Board usually has one of these problems, and the slope field is worth 2 points. They give 1 point for the 0 slopes. There's usually 0 slopes in every field. And then 1 point for just all other slopes, meaning how do your slopes look relative to your other slopes? No one's going to say, oh, really? You think that's negative 1/4 tilted? I think that's negative 1/5 tilted. They're just going to look to see how it stacks up with your other slopes. So once you've done that, we're going to move to part B, which is usually worth 6 of the 9 points. And this is why we needed to practice our separation of variables. So this is an old skill. It says to find the solution y. If you're sitting on dy dx and someone asks you to find y, then you need to integrate. Usually you would draw a slope field if you couldn't integrate. So it doesn't make like complete sense that these are paired up together. But we're going to go ahead. We do know how to integrate, so we're going to use our integration skills. So I pre-did this. This is a prereq problem. So if you'd like, go ahead and get your x's with your x's and your y's with your y's. And then you could pause the video and you could see how you did. Make sure that you solve for c at a very specific spot. They told you the 0.20. And you can see if your answer compares with mine. So go ahead and pause if you'd like. Okay, I'm going to resume. So I have the antiderivative of the left, the antiderivative of the right. Remember to never use ln if the power is not 1. So I thought of this as x to the negative 2. Then a c and a c make a c. This is where you stop, time out, find the c. I found that c equals 1/2. Then I went ahead and plugged my c back in, and I solved for y. So I dropped the ln using e. I dropped the ab value using plus and minus, and then I added the 1 over. So I had to decide if I should have a plus or a minus. I popped the 0.20 in, and it only makes sense if there's a negative there. Let's think about this together real quick. Negative 1/2 plus 1/2 is 0. E to the 0 is 1. So I want there to be a negative right here so that negative 1 plus 1 is 0. Okay, my friends, this is the antiderivative. We successfully integrated. This is the antiderivative. So the whole point of a slope field from video 1 is that it gives you an idea of what the antiderivative could be. So if we go back and look at our slope field, specifically putting our dot at 2,0, because we're told that this has a dot at 2,0. Then if we follow the slope field and just kind of do what it says, I have a negative exponential curve that's moved up 1. And oh my goodness, if I look at my antiderivative, I have a negative exponential curve that's moved up 1. So in applied math and sciences, you would use a slope field for something that you could not integrate. Very cool if you have the time to plug this into Desmo's slope field generator and look at it on a grander scale. We can integrate this though. So we were asked to do so and then hopefully have an aha moment or make a connection where you say, wow, when I drew all the slopes on some imaginary mystery curve, so you're drawing all the slopes on an imaginary mystery curve, you actually get a pretty darn good idea of what that mystery curve, what that original curve might have looked like. And since we can integrate this, we can actually confirm our suspicions. Okay, I am almost done talking at you for today. Thank you so much for listening. So the way that these slope field FRQs work is you usually get 2 points for the slope field, and then you get 6 points for the separation of variables. And then there's typically some random, generic, miscellaneous additional point, and it's on something random from the entire school year of stuff that we learned. So this random miscellaneous extra point comes from, do you remember how to do a limit? So you were not asked to draw this solution curve in, but I'm glad that I did because it's going to help me answer my limit question. The limit as x approaches infinity on the function. When the x's are getting really, really, really big, what are the y's doing? Those y's would be gravitating towards negative infinity. Okay, so what we're going to do in closing is I am going to help you get your first slope field. So you're going to turn the page, and then you're going to hit pause, and I'm going to help you get started. But then my expectations for the next couple days are that you do the next 2 questions yourself, take a picture, scan it, send it to me through Canvas. Once I've submitted everybody's, I'll post an answer key. And this is the beginning of our slope field topic. Okay, let's go ahead and hit pause. Okay, so you're going to try on your own. And then when you hit play again, you can check your slope field with mine. The rest of this question and the question on the next page, you're going to do on your own. Take a picture, send it to me on Canvas. We'll see how you did, and then I'll post answer keys and modules. Great job. Sorry that this wasn't in person. Thank you so much for listening, and I hope you all are well. Bye-bye.